Okay, we're going to work through how to do normal probabilities using a TI36 calculator, this one right here. Okay, now the calculator command, normal CDF. The first page is going to be normal CDF. By the way, this document, if you click the video description at the bottom of the page, you'll find a link to this document. You can then print this document and work along with me while you work the video. Okay? Now, normal CDF on the TI36 calculator can be found, let me get out of that, by hitting second data. You can hit the arrow over the right to DISTR to distribution, and you'll see it. It's the second one down. And when you press enter on it, you're asked for the mean and standard deviation. Since we're dealing with these here, and I like to draw pictures on these, my mean would be 0, my standard deviation's 1. Okay? And when I look at this, this tells me I want to have 1.23, and this little arrow is pointing left, so I want to shade this left. Alright? Now, the calculator command is going to ask for four things. It's going to ask for the mean. Since we're dealing with z's, the mean equals 0. The standard deviation is 1, so I'm going to put 0 and 1. That's the default. Now, the very left end of this thing is always negative 1e99. The very right end is always 1e99. So the calculator command starts with those as default. Now, the negative 1e99 is okay for the left end. But we're not going all the way to the right end. We're stopping at 1.23, so I'm going to put 1.23 for my upper end. So my lower end is okay. The default, negative 1e99 is fine. My upper end, however, is going to be 1.23. I'm going to hit calculate, and it tells me the answer is 0.8907. All right, so my answer to the first one. On to the second one. We're going to do a little bit of a variety here for the next couple of problems. Okay? Now, we're still drawing a bell curve on this. So my mean is 0. My standard deviation is 1 because we're dealing with z, so I can go ahead and write that in. Okay? Now, this says I take 2.1, and this little arrow right here is pointing right, so I'm shading this right. Now, remember, this end's negative 1e99. This end is 1e99. Okay, so my lower left end will be 2.1. My upper right end will be 1e99. So running this through the calculator, I'm going to go ahead and quit. The reason to quit is if I hit second data, oh, I'm off screen. Hit second data, over to distribution down to normal CDF. What happens, it'll reset the left and right bounds, so I get this negative 1e99 and 1e99 in there. My mean is 0, my standard deviation is 1, so we have those. Okay, my lower bound is going to be 2.1. My upper bound will be the 1e99. I hit calculate. It spits out an answer of 0.0179. I'm rounding to 4 decimal places because if you've ever dealt with the z tables, that's what they do. They round to 4 decimal places. Okay, now I'm going to move down to this one right here. So what I'm going to do is draw my picture. My mean is 0, standard deviation is 1. This time I got two numbers. I've got negative 1.8 and I have 2.2. And we're shading between them because the z is between them. Now since we're z's, the mean is 0, standard deviation is 1. Okay, now look at my picture. My lower left end will be negative 1.8 and my upper right end will be 2.2. So I'm going to go ahead and hit quit again. You don't have to. You can hit solve again. Usually that's what I would do. But I hit second data over to DIST, go down to normal CDF. My mean is 0. My standard deviation is 1. Now my lower left end is negative 1.8. And my upper or right end is 2.2. Hit calculate. It tells me 0.9502 is the answer. And you can see, you can run through these pretty quickly with this calculator because it's easy to use. It's not like the z-tables, which would require a lot of decision making for these. So now we're going to deal with the second calculator command on this. It's called inverse norm. Now the inverse norm calculator command will give you a value of z when you feed it the area. This thing always shades left. All right, so, sorry, been a very long day. This thing always shades left, so this is one of the reasons why we draw these pictures. They help identify left end, right end, which way we're shading, that sort of thing. When I draw the picture with this, I still have my mean is 0, my standard deviation is 1. Now, here's how you identify it's the inverse norm. This number's on the wrong side of the equal sign. On the whole previous page, my numbers were in here, now we're over here. Notice the arrow's pointing left, so no matter what I shade, I'm shading left. Now, this 0.1315 is the area of this curve. And I want the number here that'll give me that area. Now keep in mind, it's always shaded left, and this is shaded left, so my area can be 0.1315. My mean will be 0, my standard deviation will be 1. So I'm going to get my calculator here. We're going to hit second data, go over to DIST. This time I'm going to inverse norm. We're going to tell it the area is 0.1315. Our mean is 0, our standard deviation is 1. Okay, so I might have messed up. Nope, I didn't type in 1. My standard deviation is 1. I just mistyped standard deviation. I hit calculate. I get my answers negative 1.12. So z equals negative 1.12 for that one. Okay, moving down a little bit. Let's do another one so we get the hang of this. Drawing a picture of this. My mean is 0. My standard deviation is 1. It says I'm shading to this way this time because this little arrow right here is pointing right, so I'm shading this right. And it tells me this area is 0.8713. Okay? Now this isn't shaded left, and remember my inverse norm command needs my area shaded left. So what I'm going to do is type 1 minus 0.8713 because the total area under these bell curves is 1. Okay, I'm going to hit solve again on this one. So my area this time is 1 minus 0.8713. I got 2 points in there and it's going to say error, so I get rid of 1. Mean is 0, standard deviation is 1. Hit calculate, and it tells me z is negative 1.13. Okay, going to the next one. Now this one right here is a little trouble because we have two z's on it. Mean is still 0, standard deviation is 1. So I have negative z here and positive z here. And this area between them is 0.98. This is trouble because the inverse norm only wants this little area on the left. Well, the total area is 1, so I do 1 minus 0.98, but that gives me the area of both tails. I don't want both tails. I only want this tail right here, so I have to divide it by 2. And I can type that in the calculator right here, so I can go parentheses 1 minus 0.98 divided by 2. And then again, my mean is 0, my standard deviation is 1, so I grab my calculator. We're going to hit solve again. And now you can type this in. I can put parentheses 1 minus 0.98, close parentheses, divided by 2. Okay? And then my mean is 0, my standard deviation is 1. Hit calculate, and it tells me my answer is negative 2.33. Now, since the thing's symmetric, the correct answer should be plus or minus 2.33, but teachers vary, so some might want positive, some might want negative, some might want both, so be careful of that part, okay? But technically it is both, although some are like, no, it's only the positive, which I still understand how they get away with that. All right, let's do a couple of word problems real quick so you can see it works on word problems. Now, the beauty here is I don't have to find z's. Calculator don't care about that. Certain variety of pine tree has a mean trunk diameter of 150 and a standard deviation of 30. So we can draw a bell curve for this. My mean is 150. My standard deviation is 30. And I want the probability that has a diameter less than 115, which would look like this. Okay, now since there's no percents or percentiles in here, this is going to be normal CDF. My mean will be 150. My standard deviation will be 30. My lower bound will be the negative 1e99 again because it's on this end. My upper bound will be the shading stop, so the 115. And then I can get my calculator here, hit set and quit to get out of whatever that was. Second, data. Okay. We're going over to distribution. We're doing normal CDF. So we're going to tell it the mean is 150. My standard deviation is 30. My lower bound is negative 1e99, which the calculator already has for me. My upper bound would be 115. Hit calculate, and it tells me the answer is 0.1217. So my answer again is the 0.1217. I'm rounding to 4 decimal places. The next part says find the 30th percentile. Now percentiles are always the area shaded left. So this time I know the area to the left is 0.3. We're using 150 for the mean. The standard deviation is 30. So now I can put my area as 0.3. Since I have an area, this is inverse norm. My mean is 150. And my standard deviation is 30. I'll grab my calculator. I'll hit second quit to get out of this. Second data, over to distribution, down to inverse norm. Now we're going to type in our area as 0.3. Our mean is 150. Notice it keeps it from the previous problem, which is nice. My standard deviation is 30. Hit calculate, and my answer is 134.27, and you can see it right here. So the 30th percentile is at 134.27. All right, I hope you enjoyed a quick rundown of how to do normal CDF and inverse norm on the calculator. Hope you find it useful.